Now moving to the second problem, where the question is almost same, that we are asked to determine the surface reactions of the same cylindrical drum with self weight of 100 Newton. So here also we are asked to determine the surface reactions, but the difference is initially in example 1, this wall, this surface or this plane was a vertical one, fully vertical one, but here this plane is an inclined one. So due to this inclined plane, the contact surface is also an inclined one. We know that where there is a contact surface, a reaction force will arise perpendicular to that contact surface. So as the contact surface is inclined one, so this reaction force will also be perpendicular to the contact surface, so it will also be a inclined one. Now we need to know the angle with this reaction force. So this is our vertical axis, and here it has been mentioned that this plane is at a 60-degree angle with the horizontal. So as the plane is at 60-degree angle, so we can see here clearly, here is the plane which is at an angle of 60 degree, and the vertical reaction here, the surface reaction at this contact surface will be perpendicular, so denoting it as perpendicular to this plane. So ultimately, if we want to represent this figure over here, you can see that this was our reaction force is acting perpendicular. That means this angle is 90 degree. This is the plane, and this is the vertical line, this is the horizontal line, and here the plane is, here you can see, here the plane is at an angle of 60 degree. Angle is 60 degree, so it will be 60 degree. So from here we can say that this angle is 90 plus 60, so it will total value of the sum of all angles will be 180. So from here we will get the value of this angle as 30 degree. If we want to consider a line parallel to this one, that means these two lines are parallel. If this angle is 30 degree, this angle will also be 30 degree. So if this angle is 30 degree, then if we want to consider another line over here, another vertical line, in total the sum of these two angle will be 90 degree. So as this angle is 30 degree, the other one will be 60 degree. So here we had written that this inclined force will be having two component, force component, one is 60 degree and this one will be 30 degree. As we have determined here, this is 30 degree, so reaction force component, this vertical component, and the interior angle will be 60 degree. We had seen that these two is perpendicular to each other, so as this is 30 degree, this other one will be 60 degree, so we had written here 60 degree. So in this way, firstly we need to determine the angle, and after determining the angle, we will have to complete the free body diagram. So like the previous one, this force will also be having two components like horizontal and vertical, and then horizontal one. This horizontal one will be 50 cos 30 degree and other one will be 50 sin 30 degree. This R1 is coinciding with y-axis, that's why it will not be having any component in x-axis direction. but as the R2 force is an inclined one, it will be having two force components in x and y direction. So this is our y directional component, this is our x directional component, and we had got the angle as 60 degree. So we can conclude here that as this plane is at an angle of 60 degree, so as this plane is 60 degree with the horizontal surface, so this reaction force will be at an same angle with the vertical force component. So here is the vertical force component, and the interior angle will be same as the plane has been created with the horizontal axis. So as the plane is 60 degree, the angle with vertical component will also be 60 degree. We will be using this concept in our later examples also. So let's remember this one. Now applying summation of f of x equal to 0, we can see that r2 sine 60, the first x directional force, which is r2, as this is 60 degree, now this force component will be r2 sine 60 degree, and this one will be r2 cos 60 degree. Now plugging this r2 sine 60 degree over here, as it is acting rightward, so it will be positive r2 sine 60 degree, and 50 cos 30 is acting leftward, so it will be negative 50 cos 30. From here we will get the value of r2, and now applying summation of f of y equal to 0, we can see here the first component r2 cos 60 is acting upward, so it will be positive r2 cos 60. Then r1 is acting upward, so it will be plus r1. 100 is acting downward, so minus 100, and 50 sin 30 is also acting downward, so it will be minus 50 sin 30. We have already get the value of r2, just plugging the value of r2 over here. So we have got the value of r2 as 50, so plugging the value of r2 as 50, and we just don't know the value of r1. From here we will get the value of r1 also from this equation. And similarly we can conclude that the value of r1 is 100 Newton and r2 is 50 Newton. In our example 3, we can see now the both plane has been created as an inclined one. So firstly we will be needing to draw the free body diagram, and in order to draw this free body diagram, firstly we need to know the angles at which the reaction force will be acting. So to calculate this angle we will be using our previous concepts. So using this same concept over here, so as this reaction force is acting perpendicular as an inclined one, it will be having two force components. So one will be in vertical direction and one will be in horizontal direction. So this angle with vertical one will be 30 degree, which is same as the angle this plane has been created with the horizontal axis. So denoting this 30 degree over here, so we can easily determine this will be 60 degree. Similarly, as this plane is 60 degree with the horizontal surface, so the reaction force, second reaction force, here we have denoted it as r1. So this r1 will be at an angle of 60 degree with the vertical component, 60 degree with the vertical component. So 60 degree with the vertical component has been denoted over here. So now drawing this, completing the drawing of this free body diagram, we can see that this r2 force will be having two force components, as this is an inclined one. Similarly r1 will also be having two force components, and one in y direction, one in x direction. The angle between r1 and y directional force component will be 60 degree, as we have already explained that this angle, this plane is at an angle of 60 degree. Similarly for r2 also, this r2 will be at an angle of 30 degree with the vertical force component. Now applying summation of f of x equal to 0, we can see that in x directional forces, this first component is r2. As this is 30 degrees, it will be r2 sine 30 degree. So it's acting rightward, so it will be positive. And this one, r1 sine 60 degree, is acting leftward, so it will be minus r1 sine 60 degree. So from here we will get an equation where we don't know the value of r2 and r1. Now applying summation of f of y equal to 0, we can see that 100 Newton, which is the self weight, is acting downward, so it will be minus 100, and this r2 cos 30 degree is acting upward, so plus r2 cos 30 degree, and similarly this one will be r1 cos 60 degree, which is also acting upward, so it will be plus r1 cos 60 degree. So from here we are getting two equations, and in these two equations only two things are unknown, which are r2 and r1. Similarly in equation 2 also r2 and r1 is unknown. So we know that using two equation we can determine two unknown values. So here we can see that only two unknowns are present in these two equations, so we can easily calculate using calculator or doing by hand calculation. So by solving these two equation 1 and 2, we will get the value of r2 as 86.6 and r1 as 50. And here is our fourth example. In this fourth example, it is a bit complicated one. Here the vertical plane is an fully vertical, has been placed as fully vertical, but the horizontal plane has been inclined at an angle of 30 degree. So where there will be contact surface, there will be a reaction according to our free body diagrams principle. So as here is an contact surface, here is a contact surface, here is a contact surface, and here is also a contact surface. So there will be four reaction, r1, r2, r3 and r4. Now denoting these four contact surface reactions in free body diagram, firstly drawing this free body diagram A for ball A, and here has also been mentioned that the cylindrical drums weighs 50 Newton, so the self weight is 50 Newton. So placing the self weight also, as this is a vertical plane, so the contact surface will coincide with y-axis, so r1, no problem with this one, but this will be r2. As we can see, this is an inclined plane, and this plane is at an angle of 30 degree with horizontal axis, so this r2 will be acting at an angle of 30 degree with the vertical force component of it. So this r2 will be having two force component in x and y direction, so this r2 will be acting at an angle of 30 degree with the vertical force component. And here we can see another contact surface, so another force will arise here. Let's denote it with r4. Now as we can see that this line and this line, these two lines are parallel line, and this is a intersect between these two lines. So as this is 30 degree, this will be 30 degree, and similarly this angle will also be 30 degree. Using this angle as 30 degree, now this r4 reaction will also have two force components, like in x direction and in y direction. Now we can easily complete the free body diagram for ball drum A, and similarly we can also draw the free body diagram for drum B. Here we have this r4, so this r4 will be acting exactly opposite in this free body diagram B, So R4 is acting exactly opposite. So as this angle is 30 degree, this angle will be also 30 degree. Now here is another force R3. So this R3 will be at an angle of 30 degree with the vertical force component, as this plane is at an angle of 30 degree with the horizontal axis. Now applying summation of f of x equal to 0 at cylinder B, this one, we can see that in this free body diagram the force component for R4 will be R4 cos 30 degree, and this force component will be R4 sin 30 degree. Similarly, this will be R3 sin 30, and this is R3 cos 30 degree. Now using all the values, x directional force values, like R4 cos 30 is acting rightward, so plus R4 cos 30, R3 sin 30 is acting leftward, so R3 sin 30 negative and R3 sin 30. From here we will get one equation, and similarly applying summation of f of y equal to 0, we will get R4 sin 30 degree, which is acting upward, so positive, and R3 cos 30 is acting upward. R3 cos 30 is acting upward, which is also positive, and 50 Newton is acting downward, so it will be negative 50. So from these two equation, two unknowns, so solving these two equation, we will get the value of R4 and R3. So the values will be like 43.3 and 25. Now applying, we have already get the value of R4, so plugging the value of R4 over here and applying summation of f of y equal to 0 in figure A, free body diagram A, we can see 50 is acting downward, so minus 50 R2, so this one will be R2 cos 30, and this will be R2 sin 30 degree. So R2 cos 30 is acting upward, so positive R2 cos 30. Now R4, this is R4 sin 30 is acting downward, so minus R4 sin 30. So from here we know the value of R4 from our previous segment or previous free body diagram. We have got the value of R4. Plugging the value of R4 over here, we will get the value of R2. We can see that only the value of R2 is unknown, so from here we will get the value of R2. Now applying summation of f of x equal to 0, so R1 is acting rightward, so positive R1, R2 sin 30 is acting leftward, so minus R2 sin 30, and R4 and this component, which is R4 cos 30, is acting leftward, so it will be negative R4 cos 30. We know the value of R4 from free body diagram B. We know the value of R2 from here, so plugging these two values, we will get the value of R1. So we have got the value of R1 equal to 57.7 Newton. In this way, we will conclude the value of R1, R2, R3 and R4, which are the surface reactions that was asked in our question to determine. Thank you.